you hear it on? You hear it on?
This is bad.
Wait, can I write that
I
down?
thought, like, that was better for you.
Okay, so let's have a quick look here. All right, so this is what we didn't have much time yesterday, but we looked at a problem like this. This is pretty straightforward and simple. If we've got an inelastic collision, perfectly inelastic, meaning that the objects stick together after the collision, it's pretty easy to figure out final speed or final velocity by just using, in this case it's speed, but we could even get the direction out of this, right? Positive or negative velocity by just using conservation of momentum. Yeah, we're headed. Oh, okay. Okay. And so all we ended up doing, right, if we have two freight cars, one of them, give us both masses, one has a positive velocity initially, one has a negative velocity. All we have to do is just look at the initial momentum of the system, right? We get a positive momentum from one object and a negative momentum from the other object, and sum that up. The momentum of the system, absent any external forces, is going to remain constant. And so we end up with the momentum of the system before the collision is 508,890 standard units, so kilogram meters per second, right? Mass times velocity. What's it going to be at? What's the momentum of the system going to be after the collision? Same thing, right? Same thing. And so if the two objects stick together, then afterwards, we know that we're just going to end up with this one super object with a combined, you done with the keys?
Yeah. Because I've checked everyone out there since.
I'm totally in there. So we end up with this one super object with a combined mass of what? So add that up for me, somebody, real quick. 281 plus, so what's that going to be? 5, 7, so 679. That's a comma. Kilograms, right? And its velocity we'll just call the final, right? And we just know that the momentum, mass times velocity, has to be equal to what it was initially, right? So we get a pretty simple equation. All this stuff just gives us the equation 679,000 V final equals that. 508,890. So all I have to do is divide each side through by the mass, and what do we get? What's 508,890 divided by 679?
0.749.
0.749?
Yeah.
And how many sig figs are we keeping here? 3. There you go.
So if a moving car ran into a non-moving car, then the non-moving would just be 0.
So in this case, right, so if the second car was non-moving, it would have just been at rest, so its velocity would have been 0. So all the momentum of the system before the collision would have been invested in the moving car, right? So it would have just been whatever this, it would have just been 727, 790. Right, but because this car is moving backwards in the negative direction, it has a little bit of negative momentum.
So when you have a car not moving, then the final speed is just what? Because it would just equal itself.
But, so say it again, Lauren, I guess I'm not following.
Because like, say the yellow car wasn't moving,
Right.
so that side would just equal 0,
Right, right, but that's not a side, that's a contribution.
Well, I just mean that part
Yeah.
of it.
That contribution would be 0, right? So then we would have ended up with, the final answer would have just been whatever the calculation ended up being, when we divide 727,790 by 679,000, it would have been 1 point something, right? It's going a little slower because this one was moving against it slightly, okay? Okay, let's look at another one. I want to just talk about this one a little bit too. I like this question because it allows us to, this next one, because it allows us to think about this from differing perspectives. There's really 3 ways we could do this one. Okay, so what about something like this? And this is actually how you do a ballistic test, it's ballistic trap. So what if you have a light bullet, 33.8 gram, obviously that's not standard units, we'd have to convert, strikes a 64.3 kilogram stationary wood block and embeds itself in the block. The block and embedded bullet fly off at a speed of 0.52 meters per second. The bullet had an initial speed of what? Well, how would you approach this one? Describe the system before, after the gun is shot, but before the bullet strikes the block. What are the parts included in the system that we're talking about?
Bullet in the block.
Bullet in the block, okay. What's the momentum of the block before the bullet strikes it?
Oh, the momentum of the block?
Be 0, right? Yeah, because it's not moving. So all of the momentum of the system at that point is invested in the bullet, right? After the bullet strikes the block, then the bullet and the block become one super object, right? They're combined. Bullet's embedded in the block. And so really all we'd have to do is take the momentum of the system divided by the combined mass, and that ought to equal 0.562, right? Or the other way around, I guess, trying to find the initial speed, right? So we know what the momentum is afterwards. The momentum of the bullet before has to be equal to that, correct? Anybody buy that? Okay. All right. So this really is this is the same question we just did, isn't it? Right? Inelastic collision.
But
Okay.
backwards.
But backwards, exactly, backwards. Okay, what about,
We're ignoring the fact that it
Can we do some of these
had
problems?
to.
you want to go through that last one together?
Oh, I just erased it.
Can we just look at it?
Act like.
I mean, we can set it up and
Actually find out the answer.
yeah, so I mean, let's at least set it up like before and after. How about? So before, we'd have, let's just call it little m would be mass of the, well, we'll do it, m sub little b and m sub big B. Okay, so we end up with before the momentum of the system, right, momentum total, equals the mass of the bullet times the velocity of the bullet plus the mass of the block times the velocity of the block. And remember, this whole thing right there is just 0, right? Afterwards, we know that the total momentum is going to be just one object, right? So it's going to be the mass of the bullet plus the mass of the block. That's just the total mass, isn't it? Right? Times the velocity of, what do we call this? B plus B, little b plus big B. So the velocity of the two combined, right? Well, we know momentum is conserved, and so these two things have to be equal. So those two expressions have to be equal, and there's our equation. What's the only unknown in that whole system?
Velocity of the bullet.
Velocity of the bullet, yeah. So that's what we're solving for, right? Okay, momentum is conserved. Okay, does that make sense? Questions on that? Okay, so next step. Next step is I want to consider, was this the, where is it? Yeah, this guy. Okay. Somebody tell me a method for finding the answer to, well, what's impulse, by the way?
Delta,
Say it again.
change in momentum.
Change in momentum, right? That's the definition of impulse, is change in momentum. So part one's pretty straightforward, right? The initial momentum of the bullet is 0. Final momentum is 2.0235 kilograms times 1,004 meters per second, whatever that is, right? Okay, but part two, the average force acting on the bullet. Somebody tell me a method for finding the average force acting on the bullet.
Mass of the acceleration.
Okay, so
Equation
we know the mass. How could you calculate the acceleration?
equation.
Yeah, you could use kinematics, couldn't you? Right? Think about the bullet in the rifle. What are the quantities? And so this takes us back a long ways, and we've got some better ways to do this now, but I want you to see that there's a bunch of approaches you could take to this. They're all going to give you the same answer, right? So if we were to use kinematics, what are the kinematic quantities while the bullet is in the rifle? Tell me some stuff you know about that.
Velocity 1 or 9 is 0.
Okay, so the initial velocity is 0.
And then final is 10.
Final is that, 1,004, right? Standard units. Okay. What else?
Distance is,
Ah, okay, good, displacement. Yeah, we know delta x is 0.661 meters. We convert that to meters. Right? Okay, what else? I guess that's it, isn't it? But that's all we need, right? There's no time there, but if we use kinematics equation 4, the one that doesn't have time, we can solve for acceleration, right? We know that v squared minus v naught squared equals 2a delta x, right? And so all we'd have to do is just solve for a. We have everything else, right? So we could find acceleration, and what's force? By Newton's second law.
Mass of acceleration.
Yeah, F equals ma, right? So then we know that the force would just be whatever we calculated for the acceleration times the mass in kilograms, right? Okay, no big deal, right?
And the impulse is what?
Impulse is just change in momentum, right? We've really only got all this collision stuff. There's really only 2 equations. Here are our 2 equations, and they say exactly the same thing. Impulse capital I is just change in momentum, which is F delta T. Equation 2, all we're doing is multiplying or dividing each side by delta T. Equation number 2 is our revised version of Newton's second law. F equals delta P over delta T. That's it. That's the only new stuff we've added in Unit 6, right? Okay, so that's one way to do it. What's another way? Say it again.
Solve for the amount of time.
Okay, so we could solve for the amount of time it takes for the.
Divided by 2, and then displacement divided by velocity.
Okay, yeah, good. So we could use our new stuff, couldn't we? We could use this equation right there. Right? We could use our true definition of force, and the change in momentum is easy. We calculate that right there, right? That's just final momentum minus 0, right? To find the That's right. To find the time interval, all you'd have to do is just use the fact that, well, what kinematic equation would we use to essentially calculate delta t? I mean, you could use a lot of them, but really it's just number one is all you need, isn't it? Right? We could use number one, which is delta x equals average velocity times delta t, right? Average velocity is just the average of 0 and 1,004, so what, 502, right? So 502, it goes there, delta x is 0.661 meters, so 0.661 divided by 502 is going to give us the amount of time it takes for the bullet to exit the barrel, right? And if we have that, we just plug it in right there, right? No big deal. So we got two good methods, okay? What's another way?
Could you use work?
Yeah, the preferred way, in my opinion, would be to use work and energy. They're not vector quantities. That's the way I would definitely approach this one. So what does the work energy theorem tell us? The net work changing kinetic energy. Yeah, right? So the net work is the same thing as the work due to the net force, right? So net force times delta x, right? Force times displacement. And that equals change in kinetic energy. So there's only one force acting here, right? We're ignoring friction. There's only one force acting, and that's what we're trying to calculate here, right? Force acting on the bullet. I guess that could even be a multitude of forces. All we care about is there's one net force acting on the bullet that makes it do this stuff, and so that's what we're talking about right there, is the average force, right? Okay, so there it is. That's what we're trying to find. We know what delta x is, right? What's the change in kinetic energy? That's easy. What's the initial kinetic energy of the bullet?
0.
0. Final kinetic energy?
A lot.
A lot. Just going to be 1/2 m, which is right there, times v squared. Well, there's my speed right there. That's probably the easiest way, isn't it, to me? You don't have to do much calculation at all, right? Everything there you know. So we could say that F equals, if I write that as one big fraction, I just get mv squared over 2 delta x, right? Okay, no vectors, right? It's a good way to do it, okay? All right, we'll look at one more from one of the later assignments here.
These are all examples of the assignments you just put up.
Yep, these are just all off the new assignments. So let's look at, I think it's this one. Oh, I know, it's on the last one. That's right. Okay, same kind of problem, right? Just in reverse. Everybody agree?
Why doesn't this block?
This time the bullet's coming in hot and it's coming to rest. Same idea though, right? There's going to be some force acting on the bullet to decelerate it. So that's literally just a time reversal of what you just did. Okay, here's the one I want to look at. Let's look at this guy. There's really only one problem on the last assignment that's really tough. And we haven't learned how to do that yet. One of them will be enough, I promise you. So what about this? A rifle shoots a 40.4 gram bullet with a muzzle velocity of 1,083 meters per second. The bullet comes to rest after penetrating a stationary wooden block on a frictionless surface. What fraction of the combined energy of the bullet and the block is lost during the impact? Okay. So how are we going to do this one?
Find the initial kinetic energy of the bullet.
Okay, initial kinetic energy of the bullet, because all of the energy in this whole system, there is no potential energy, is there? Right? It's just all going to be kinetic. All the mechanical energy is kinetic. Okay, so let's make that calculation. Let me just copy this thing. There's something pretty cool that comes out of this. I want to get back to baking cookies. Talking about baking cookies.
What is the?
That's always
what do
good.
they do for physics?
Didn't we say the 20th?
Did we?
Thought we said the 20th.
No, Amon just made that up.
Oh,
I'm telling you, I said
odd.
the 20th.
well, you guys can, let's pick a date.
I said we scratch it.
No, we're not going to scratch it.
Can it be a side project?
What do you mean?
Can it be the last day of school?
Are you asking if it can be optional?
It should be like
Is it? Is it
really
the final?
heavily weighted so that
Graded.
it. Yeah,
Is it the
Is it
final?
graded at all? Is it the final?
That could be our final.
that should be.
Ah.
Yeah.
Yes.
Which means, do we have any more tests between now and then?
Yeah,
How many?
not many.
Not
Not many.
That's
Well, that's all.
However many it works out to be.
That's all. That's all in reference.
How many
So
did we
there-
have?
a plethora of
So I'm going to pull up the calendar right now. Let's just set a date here. You guys are the ones that have a ton going on. So here's the calendar. What do we know about?
better yet, June 3rd.
Yeah, June 3rd.
I like June
I like
3rd.
that.
Yeah, let's say June 6th.
June 3rd. What's going on June 3rd? You guys are
That's a-
done on June 3rd,
It's
aren't
a
you?
Sunday.
No.
Oh, we're not
Not
that.
to mention 3 days after we graduate.
We just come here and show.
I'm still gonna come to
show
school
you
after I
what
graduate.
it's
Because I want.
Okay.
Make the catapults like smaller.
They can't make me
Like,
stop.
Can't
Make everything really small.
I
They're-
know,
aren't they
I'm
pretty
going to
small?
because
They're
I
pretty
don't have
small.
a 3D printer working yet.
I
These 3D
don't
printers
have
work.
the rubric still.
I
Okay.
was told I had to make this stuff.
We don't have to be that small. The last
Two
year.
years this weekend. I have to work this weekend.
You know, McDonald's.
You
Don't
wanna
worry,
run this
Rylan.
on McDonald's? We can do it there. Yeah, there we go. All right. I work at McDonald's. That's why
Why
they're
would
coming.
you
That's
do that at McDonald's?
because I work there.
I can make one every time you guys have work.
Don't worry, Rylan.
You know,
Sarah and I can
Me and Walter have first period together at that
Well, like,
P-Tech.
relax.
so we can laser engrave
So we
everything.
can do most of the stuff there.
3D print everything and then
I
like.
can't
Well,
hear you very
yeah,
well,
laser
so-
engraver
I
will
can
work better
do
because
that.
then we can engrave larger pieces than we can print.
I can do after schools.
You want a Minecraft
It
village?
doesn't need, it doesn't need to be very big though.
Okay, so.
It doesn't need to be that.
Right,
you could
but
then
like
tell us
3D
this
printing it
class,
would
I guess.
take a very long time. It's a
Mhm.
very
I'll just
easy
catch
laser
up.
engraver. Unless we got all 6 working at the same time.
I can drive.
Took them over, taken
No,
over
that
the rest
was
of the year like we did last year. Even though that was all year. Was it River?
I don't know who would want
Yeah.
it. I don't think you don't really
So tired.
Can I pick you
Me
up?
too.
I need to push it now.
Okay, trebuchets. Let's get this thing settled for once and for all here.
All right.
Let's do the 24th.
What's on the
The
24th?
15th.
No, the
No,
25th.
15th is too soon.
The 25th.
Let's do the 20th.
15th?
Tomorrow. We have to have it done tomorrow.
Okay, we have to realize there's people going to outdoor school and bio.
Bio.
Right.
The 25th
15th,
is like
16th,
the
17th.
last full week
And graduation
we have,
stuff.
right? Second last.
After the 25th,
We've got one
we
more.
have
Right.
like 2 more days. or
Current
something.
are due by this.
Okay, so
Yeah. Really? I thought we graduated the 3rd.
Graduate on the
okay, so calendar. What are we looking at here?
Yeah.
Alright, so.
Let's highlight some stuff in here. So what are the days of outdoor school? You guys are what week? Who's going to outdoor school?
I'm going first week, which is the 9th through the 11th.
9th through the 11th. Okay, anybody going second
That's
week?
next week.
I'm going, I'm not going second week.
Anybody going third week?
But the,
So just one person going to outdoor school? Aren't you going, Nick?
I said third week.
Oh, third
Oh, I
week?
didn't raise
I was gonna
my
say.
hand.
So who else? So we got 2 people going, that's it? So we got 9th through, so Seth's gone 9th through 12th?
9th through 11th.
9 through 11. Okay. Nick's gone 23 through 25.
Yes.
What about the biology trips?
16th through 19th.
16, okay, let's get this up.
We'll do it on the 22nd.
I was gonna say the
15
29th.
15 through 17.
15
That's
through
our
17 is
last
bio.
meeting.
You can do
So
it.
the second half of that bio trip week is open technically.
Okay, so 16 through 19,
15 through 17.
15 through 17.
Yes. That is.
So that's bio.
Yep.
And who's on that trip? Raise your hand. Okay, a lot. Okay, so that's for sure, that's out.
This class is gonna be a lot of fun.
Okay, so there's the bio trip, really it's just the bio trip
And the
and
2 weeks of outdoor school.
the 2 weeks of outdoor school.
Plus whatever golf I'm going.
Well, I mean, there's gonna be regular
Wait,
stuff,
when's state for track?
States, I can't remember. End of May. Yeah.
Actually, it might be like,
It's either the 18th or the 25th.
I think it's like April. I think it might be like
Whoa,
April.
whoa, whoa, whoa.
Well, let's see, today, so
No, no,
next
no,
week's
it'd be-
districts,
it'd be-
state's gonna be the 25th.
Yeah.
Yeah. Because isn't it 2 weeks after districts? It's a week and a half after district. No, it's gonna be the
It's that.
18th.
Yeah.
It's gonna be the 18th, yeah.
Mm.
It's the 18th, okay. So then that whole week, then that's gonna be potentially some people. We'll see how
So
that
that
works
whole
out.
week is
That's
a work
potentially gonna be some people
That's just.
right there, so that's a bad week. Okay, let's see, what's the other one we gotta think about? Outdoor school. So when's outdoor school start? Next week?
The 9th through the 11th is.
Okay, and that's just one person though, right? Okay, so that's
Yeah, don't worry
Seth,
about me, guys.
No, that's a very important
That's
person.
very
and
important.
then Nick, you're 23rd
Yeah,
through 25th.
yeah.
So let's
do it on the 26th.
No, the 29th.
Probably
Let's do it the 29th, so that way it's our last week of school.
I thought these
So
were
guys,
going in
the
the grade
29th is a
book.
holiday.
When's,
No, it's
what
not.
is your last day of
28th is
school?
I think our last day is either the 30th or the 31st.
That's the
It's
third.
the 30th.
30th?
The
This is
29th
last-
is the-
That's right, are these going in the grade book?
So here's what I'd be willing to do, because this is gonna be, I don't know why, every year this happens, and I don't know why I don't get smarter about this. How about if we say this, I will say that the trebuchet, I have to have a deal from it.
Is it bonus points?
I have to have honest effort to make this thing worth doing, but I'll say it can't hurt your grade. It can only help your grade.
Yes.
Okay, but you gotta, my price of admission for that is I wanna see good trebuchets, okay? You gotta do a good job.
Can
Right.
Will we get a very good grade if we ripped your pace on it?
Say it again?
If we ripped your pace on it, will we get a good grade automatically?
Well, that could only help, of course, but.
Okay, what if
Here we
we
go.
had our
Write that down.
own restrictions that we put on ourselves? Like, what if Richard and I took a challenge to like only make out of biodegradable materials? Would that be like extra like kudos power?
Well, you can, if you, I don't know, I would just try to make a winner.
So then we're doing.
So let's do this then. How about if we say, yeah, we're getting down there. So let's say we're gonna go, these will be the days that we'll set aside for trebuchet. We'll go 22, 26.
That's a Saturday.
That's a Saturday.
Okay, you guys take that day off. Let's go 21,
We can still show
22,
up.
28, 29.
28th is a holiday.
20th is Memorial Day.
Okay, take that one off too. Man, you guys going all these days off, aren't you?
21, 22, 29, and 30.
I'll be here forever.
21, 22,
27.
29.
27.
27.
We could probably do that. We could probably do that, which means we need to be done. So that means we need to be done with stuff
The 30th.
by the 25th. Okay.
Yes.
That works. Okay, I can work around that.
For a lot.
I think we're not gonna need that many. I think the trebuchet is gonna take 3 days, I believe. But this will give us an extra day in terms in case the weather is bad or something. Okay.
What voucher are you going?
If we,
Nick, who's in your group?
Oh, that's the best.
if we,
Richard?
yeah.
Okay. Who's gone? And then the 19th, that's track, right?
Yeah.
19th Saturday.
I'll be gone for that probably anyway, so
Wait,
that's
what?
If we need,
Yeah.
if we
Saturday.
decide to do what needs to be,
And then if
like,
we need another.
18th, 19th.
like,
Yeah.
we're doing
Well,
like
we
grade
need
A
a
stuff.
plan before the
I
end.
can also in grade third
Yeah.
period.
Let's say this. Is that good? We good with that?
Sure.
Yeah,
Okay.
just set it so then we can think, otherwise we're never gonna think of it.
Yeah, let's do that. So those are, put those in your book. Write those in your notes. Those are the trebuchet competition days. Okay, weather should be nice. It'll be Bring
It'll be just
food
like
for our
this.
trebuchet battles.
It'll be just like this.
Yeah, can we get
This
excused
will
from
be-
classes, just do an entire day?
Probably can't do that.
Can we get excused from A class and do 2 periods?
I could, I'll tell you what, maybe we could do is we could use TA on those days. I could see,
Oh yeah, because the TA and
Could
the
you set
possibly,
up
or at least a
those,
couple of
yeah,
those
seven
days.
markers.
Yeah.
Okay.
Can you put the requirements for the?
Oh,
Yes, I'll put those up right now.
I'm gonna be gone on the 22nd. That's just like a.
What's the 22nd?
Just like a leadership thing.
Yeah, but it's only one
Okay.
person. We'll keep going.
Okay, so we'll do this then. We'll go, how about if we do this? We're gonna go, I'm gonna add those, we're gonna go 20, those are, the green circle days are our days. Okay, so that way we can maybe have like a battle,
Those are like.
we can schedule this so we have a battle, you could battle on the 23rd, and we'll see if we can,
But we're in groups, so like groups.
that's true, yeah. Okay, 21 through 23, 29 and 30 if necessary.
And those are those like 25 work days? Or what do you?
Those are, yeah, those are competition days.
21st and 22nd.
What is that?
21st, 22nd, 23rd, 29th, and 30th if necessary.
21st and 22nd are like preliminary, and then we can finish it up with 29th.
What is the champion rank?
Possibly. Fabulous gifts and prizes.
What comes in
You
that?
should bring candy.
Candy
Or
for sure.
ice cream.
Candy and ice
Bring
cream.
graham
Yeah.
crackers for us.
King size.
No.
King size
Ice
candy.
cream.
Can you give us A's?
Graham crackers.
For snacks.
Okay.
Graham crackers are great snacks. They make your mouth dry.
Let's bring
So-
vanilla
so
That's
bean.
why you put frosting on it.
So that makes you fat.
You just put butter on those.
Right.
You contribute
You
to
should
corporate
make
greens. We should make our own.
Wait, not.
You can make your own.
Really?
I eat my own.
You have to
clothes.
grow all of your
I
food too.
press
I
grass
can't build
in the
that.
kitchen.
I can't do that.
I grow my own clothes.
You can make your own graham crackers.